Okay, we're going to look at some stoichiometry practice problems. In the first one, if you look at the actual written text, it says how many liters of ammonia would be produced by the reaction of 847 liters of hydrogen. So we're going from liters to liters. And when you're working with liters, that means we do not need to find the molar mass. Remember, the molar mass is that thing that we calculated usually on the upper right side of the board or of the page, and the molar mass is grams per mole. And that's very useful, but it's only useful if you're dealing with grams. In this particular question, we're dealing with liters, so we do not need to find the molar mass. So let's do it step by step. The first thing is to check and see if the equation is balanced. Yes, it is balanced. The next step is to write the given information above the chemical equation. It says that we have 847 liters of hydrogen. So let's put 847 liters above the hydrogen. And the question is asking how many liters of ammonia. So let's put an X above ammonia because we don't know how many liters that is. Next, let's put the moles underneath. We have 3 moles of hydrogen. We have 2 moles of ammonia. And at this point, we can cross out the stuff that we don't need to make it easier. So let's cross out the nitrogen. We don't need to worry about the nitrogen for this question. Next, it helps to sort of conceptualize what you're going to do. So I like to draw arrows. Starting with what we're given, we're going to turn that into moles. And then we're going to turn those moles of hydrogen into moles of ammonia. And then finally we'll turn the moles of ammonia into liters of ammonia, and then we will have the answer to our question. So the way we can do all those conversions is by using dimensional analysis. And that's that long math question that you write out, or the long math formula, rather, that you write out. So we have 847 liters of hydrogen. And let's convert that to moles of hydrogen. I'm just following along with my arrows. We start with liters and we go to moles. So liters goes on the bottom so that I can cross it out. Moles goes on the top. In 1 mole, there are always 22.4 liters. That's a standard. Next, let's see where the next arrow goes. The next arrow goes to moles of NH3. So I'm going to go to moles of NH3. Moles of H2 goes on the bottom. Oops, I forgot to write mole. Moles of NH3. Moles of H2. And this time you look at the ratio. Let me circle it. You have 3 moles of hydrogen for 2 moles of NH3. So you put a 3 next to hydrogen. You put a 2 next to NH3. So this cancels out. And now finally we only have one more step to go. If you follow that last arrow, we're going to go from moles of NH3 to liters of NH3. So liters goes on the top, moles goes on the bottom, so we can cross out the moles. And then we need to plug in our conversion factor. The conversion factor from moles to liters is always 1 mole is 22.4 liters. Let me dictate out loud what you're going to type into your calculator. Remember, if it's on the top, you multiply. If it's on the bottom, you divide. So you do 847 divided by 22.4 times 2 divided by 3 times 22.4. And you will get your answer in liters of NH3, ammonia. Number 5. Let me find the question here. Okay, it says what volume of oxygen, so that's what the question is asking, what volume of oxygen, so we put an X over that, would be needed to produce 62.5 liters of sulfur dioxide. 62.5 liters of sulfur dioxide. Let's do our moles next. At the bottom we have 1 mole of oxygen. We have 1 mole of sulfur dioxide. Let me draw the arrows next. We're going to take what we have in liters, turn it into moles of sulfur dioxide, turn it into moles of oxygen, and then finally turn it into liters of oxygen. You're always going to start your arrow with what you know and then end it with what you do not know. And then just follow your arrows, follow what you wrote. First we're going to take 62.5 liters of SO2. We're going to convert that to moles SO2. So liters of SO2 goes on the bottom. We can cross that out. The conversion between moles and liters is always 1 mole is 22.5 liters. Next, we got to go from moles of SO2 to moles of O2. Moles of SO2 goes on the bottom. Moles of O2 goes on top. Now for this ratio, you got to actually look at your mole numbers that you wrote down. This one's 1 to 1, so that's easy. We can cross these out. And then finally, we're going to go from moles of O2 to liters of O2. So we can cross out the moles now. The conversion factor between moles and liters is always 1 mole is 22.5 liters. So into your calculator, you can plug in 62.5 divided by 22.5 times 22.5. I left out this part just now when I spoke it out loud, just because it's 1 over 1. So you don't need to type that in. Okay, number 6. The question is, what mass of antimony chloride? So let's put an X over antimony chloride. I'm going to put a little parentheses and say grams, because last time we wanted liters, but this time we want grams. Would be produced by reacting with 112 liters of chlorine. Okay, so let's put 112 liters above the chlorine. Let's do the moles next. We have 3 moles of chlorine, and we have 2 moles of antimony chloride. So with your arrow, you're going to start with what you know. We're going to turn the liters of chlorine into moles of chlorine. Then we're going to turn the moles of chlorine into moles of antimony chloride. Then we're going to turn the moles of antimony chloride into grams of antimony chloride. So for this one, you need to do your molar mass. You need to figure out the molar mass of antimony chloride, because we need the grams. Anytime you see the word grams, whether that's what you're starting with or that's what you're ending with, you need to find the molar mass of that compound. In this question, there's only one thing that we see grams for, and that is antimony chloride, SbCl3, and we need to figure out the molar mass of that. So the way you can do that is by taking the mass of antimony and then adding it to the mass of chlorine times 3, because there's 3 chlorines. So you have to look at a periodic table. If you're sitting at home, you can either do this on in your textbook, or you can Google it and find one online. Antimony is, I gotta find it. Where is antimony? Let's see. Antimony is 121.76 grams per mole, and chlorine is 35.45 grams per mole. So what you do is 121.76 plus 35.45 times 3. So this whole thing, 35.45, that whole thing is times 3. And then you add it to the 121 and you get your molar mass. I'm not going to do it for you. You can figure that out on your own. Okay, let me get my eraser and erase that. So you need to have that number, and you got to write it down somewhere. Now we can solve the problem. We're going to start with 112 liters of chlorine, and the first stop is to go to moles of chlorine. So the top is moles of chlorine, the bottom is liters of chlorine. I've said this before, but I want to make it very, very clear. What you put on the bottom in the denominator is always what was on the top over here. So if you have liters of chlorine on the top, then you're definitely going to have liters of chlorine on the bottom of the next one. So anyway, let's plug in our conversion factor here. The conversion between moles and liters is always 1 mole is 22.4 liters. So now we can cross out our liters of chlorine. Next, let's go to moles of antimony chloride. So we have moles of chlorine on the bottom. There are 3 moles of chlorine, and there are 2 moles of antimony chloride. I got that by looking at these numbers right here. And then finally, we're going to go to, this is moles of SbCl3, we're going to go to grams of SbCl3. So these two numbers right here, I'll use the letter X. These numbers here are what you got when you did your molar mass. When you did your molar mass, you got grams per mole. So on the bottom where it says mole, you just put a 1. And on the top where it says grams, you write the number of grams that you got. So if you got like 200, then you would put 200 up there. And then you'd multiply it all out. Make sure you multiply the numbers on top and you divide by the numbers on the bottom. Number 7. We have, it says how many grams of sodium hydroxide, so let's put an X over sodium hydroxide, would be required to react with 400 grams of sulfuric acid. So let's put 400 over sulfuric acid, 400 grams. And so we have grams twice here now. Let me put grams in parentheses again. We have how many grams will react with 400 grams. Let's do moles now. On the bottom we have 2 moles of sodium hydroxide. We have 1 mole of acid. I don't think I did this in the last one, but you could cross out the ones that you don't need. And then with our handy arrow, we draw it from what we know all the way to what we don't know. Okay. So you're going to have to find a couple different molar masses here. Go over to your molar mass station. You have to find the molar mass of NaOH. You can do that by adding up the mass of Na plus the mass of O plus the mass of H. You also need to find the molar mass of H2SO4. You can do that by doing 2 times the mass of H plus the mass of S plus 4 times the mass of O. You will need those 2 numbers in order to complete this problem. Okay, so now let's go over and write it in. Let's start with what we're given, 400 grams of H2SO4. And then we're going to put that into moles of H2SO4. There's going to be a 1 next to the mole, and then where the gram is whatever you got for your molar mass. I don't know what it is. And then we need to go to, let's see, we have moles of H2SO4 on the bottom. And on the top, we have moles of NaOH. There's 1 mole of H2SO4 and 2 moles of NaOH. And then we do one more calculation. We can cross this out. I'm going to go down here to another line. I ran out of space. On the bottom is going to be moles of NaOH. So we can cross that out. And then on the top is going to be grams of NaOH. So where the grams is going to be the number that you got for the molar mass. There's going to be a 1 next to the mole. So you do 400 divided by your molar mass of sulfuric acid times 2 times the molar mass of sodium hydroxide. And then you will get your answer in grams of sodium hydroxide. Alright, number 8. The question is how many liters of hydrogen? So we can put an X next to the hydrogen. And then we have 88.5 grams of ammonia. 88.5 grams of ammonia. So we only need to find 1 molar mass here. Let me put liters in parentheses so that you don't forget. Our hydrogen is in liters, so that means we do not need the molar mass. But the ammonia is in grams, so you do need to find the molar mass of ammonia. So before you even start, come over here and figure out the molar mass of ammonia, NH3. This one's easy. I'll just do it with you real quick, because you can kind of do it in your head. N is 14, I believe, 14 grams per mole. Hydrogen is only 1 gram per mole, but you have 3 of them. So 14 plus 3 is 17, so your molar mass is 17 grams per mole. So make sure you write that number down. You're going to need it in a minute. Molar mass of NH3 is 17 grams per mole. Okay, now we're ready. Oh, let's write moles on the bottom here. We have 3 moles of hydrogen. We have 2 moles of ammonia. So now we can solve. Let's start with what we're given. 88.5 grams of ammonia. First step, turn it into moles of ammonia. Moles of ammonia. So then your grams go at the bottom, so you can cross it out. The conversion factor between moles and grams is what we just figured out. In 1 mole, there are 17 grams of ammonia. Next, we're going to convert to moles of hydrogen. There are 3 moles of hydrogen and 2 moles of NH3. I just got that by looking at these numbers here. And then finally, we're going to go to liters of NaOH. At the bottom, we have moles of NaOH. So this one we know. Anytime you go from moles to liters, it's always 1 mole is 22.4 liters. Always. So to get the answer, you do 88.5 divided by 17 times 3 divided by 2 times 22.4. And you will get your answer in liters of NaOH. Looks like I didn't draw my arrows. I'll do it real quick, just to be consistent. Okay, I believe this is our last question, number 9. How many grams of water, so that's the unknown, let's put an X above water, would you need to decompose by electrolysis to produce 112 liters of oxygen? 112 liters of oxygen. Okay, so we're going from liters to grams. Let me put that in parentheses so that we don't forget. Grams of water. Let's put the moles at the bottom. We have 2 moles over here. We have 1 mole over here. We can write our arrows. We're going to go from what we know over here to what we don't know. So think about this. Do we need the molar mass of anything here? You only need the molar mass when you're dealing with grams. So it looks to me like we only need the molar mass of water. To find the molar mass of water, water is H2O. So you have to do 2 times the mass of hydrogen, which is 1, plus the mass of oxygen, which is 16. So the mass of water is 18 grams per mole. This is something that you'll probably have memorized by the end of the week. Water, 18 grams per mole. It's a very common molar mass to use. Okay, where were we? Let's solve this thing. We're ready to solve it. Let's start with what we know. We have 112 liters of O2. Let's go to moles of O2. There are always 22.4 liters in 1 mole. That is always the conversion factor between moles and liters. Next, let's go to moles of H2O. Take a look at the mole numbers that you wrote down. You wrote down 1 mole of oxygen and you wrote down 2 moles of H2O. And then finally, we can go to grams of H2O. Okay, so you got to think about what your conversion factor is between grams of H2O and moles of H2O. Well, that's the same as the molar mass. So in 1 mole of H2O, there are 18 grams. So when you type this into your calculator, what you're going to type in is 112 divided by 22.4 times 2 times 18. And that will give you your answer in grams of H2O. Okay, I hope that this was helpful.